Yeah, very good Friday morning to everyone. A brief welcome to GoodWe's Hybrid Inverter Product Training webinar. My name is Steve Davey, and I'm a consultant to GoodWe, representing GoodWe's European, Middle East, and Africa team as the head of business development for our region. And I lead the Sub-Saharan African team with very credible technical support of both David Havenga and Warren Elliston. As many of you may know, many of you know David already. He is our after-sales technical support manager for South Africa. And David has a very capable, practical understanding of GoodWe's products, batteries and hybrid inverters. Hybrid inverters in particular, and is an important part of the Sub-Saharan. And then Warren Elliston is a very well-qualified engineer with good experience within the South African PV industry. And Warren is our pre-sales technical manager and will be supporting myself with project developments in the C&I and utility space. And Warren is also clearly a very important ingredient to GoodWe's growth into Sub-Saharan Africa. And so we decided to offer this webinar training to help address some of the common technical support questions which we receive on a daily basis. And as we've been growing, as GoodWe has been growing quite substantially into South Africa, the support demand has also increased for GoodWe products. And unfortunately, we've not been able to offer any hands-on or face-to-face training for obvious reasons because of Corona or COVID so far this year. So we've decided to offer the next best thing, which is this webinar. And GoodWe has come quite a long way in the last year since putting together a dedicated team to develop the local markets in South Africa and Sub-Saharan Africa. So as of yesterday, we had 230 people registered for this training, and I'm sure that more have registered since then. I think by the end of this webinar, we should be able to have a final number on that. But this definitely speaks to the strength of GoodWe's brand and the local support structures which we are implementing to offer a dedicated focus to the South African market and also into Africa. So maybe before we get started on the presentations, just some formalities. So please use the Q&A function, the Zoom Q&A function for any questions that you may have. And not the chat box. The chat box, we would rather, it gets a bit too complicated and maybe a little bit messy trying to address both the chat box and the Q&A. So please only use the Q&A function for your particular technical questions. And then we'll do our best to answer those questions in the Q&A section throughout the presentations, but we will also be addressing Q&A questions at the end after all three of our presentations are done. So I'm going to start off with a brief commercial overview of GoodWe as a company, just to help give some context. And then Warren will give his presentation on the design and installation considerations for hybrid installs. And then David is going to give his presentation on the installation and commissioning of hybrid inverters and things to look out for and things to consider in the setup of the inverters. So, and then also finally, between each of our presentations, there will be a short question poll. And then at the end, we will, we'll open it up to Q&A. So please, if you can participate in those question polls between the presentations, there will only be 2 or 3 questions. each time. Very simple questions, but just some questions to help us better understand the market and where you are as installers and distributors. So yeah, with that, yeah, we'll get started. Just give me a second quickly just to set up my notes. Okay, so before I get started on GoodWe, just a quick introduction on my background, just so that everyone understands who I am. I've been in the international PV industry for 15 years. I started in the USA in 2005 during my studies. I studied engineering in the US and was part of the initial PV industry growth in the US, working for EPCs and also inverter OEMs during my time there. And then I moved back to South Africa in 2012 and was part of the REAP round 1 to round 3 as country manager for Bonfiglioli. And I've also led and grew the local team of Canadian Solar to become market share leaders in sub-Saharan Africa, and others, and a few other companies also before taking on the business development consulting contract with GoodWe. So in addition to consulting and advising in PV, I also invest and trade in medical, the food and beverage industry, and also other solar ventures. However, you know, I have taken on a reasonably dedicated focus with GoodWe and developing the market for GoodWe. Yeah, moving on to GoodWe. So a little bit about the company and overview. So GoodWe is a top 5 global PV inverter manufacturer, which is headquartered in Suzhou in China. And it has, it's also got an extensive portfolio of grid-tied, hybrid, and storage inverters ranging from 700 watts all the way up to 250 kilowatts, with our latest product that we bring into market. And then since, yeah, the slide hasn't been updated recently, but you can see there that the global installation base, the cumulative global installation base for GoodWe is marked as 12 gigawatts. We recently hit the 13 gigawatt mark there. Also worth noting is GoodWe has over 1,000 employees globally, of which 200 or 20% approximately are R&D staff. And that definitely speaks to GoodWe's strategy in terms of product development and the emphasis that we apply to the technical capabilities and also the levelized cost of energy of the products which GoodWe brings to market. Okay, and then a little bit about the global presence of GoodWe. So we are present in all major markets globally. The biggest one being China, and also the UK, Germany, and the Netherlands, which are the two most active. The Netherlands, which is probably the most active market in the world at the moment, but also big markets such as Germany, and many of the dedicated markets into Europe, also Australia, South America, and obviously South Africa. So most of the major markets globally. And then in terms of market share in distributed PV, GoodWe is #1 in China and also the Czech Republic. GoodWe is also #2 in Australia, but very aggressively pursuing that #1 position, which we are looking to achieve within the next year or two. And then also #3 in the Netherlands for the entire portfolio. And again, with the Netherlands being probably the most active PV market globally, I think speaks a lot to where GoodWe is. And then according to IHS Markit, GoodWe is a top 4 manufacturer for three-phase string inverters, and also aggressively climbing up those ranks there. For the entire product portfolio, Wood Mackenzie rates GoodWe as a top 7, and that rating was from 2019. And GoodWe, based on the trend and revenue numbers, GoodWe is definitely climbing in those ranks also. Okay, so a recent announcement, very recent announcement, is that GoodWe has again achieved the TUV Rhineland All Quality Matters Award for the 5th year running. For those who don't know, TUV Rhineland, they're a global certifications agency, very credible certifications agency, and they also run this All Quality Matters Award each year. And this is, again, the 5th year that GoodWe has achieved this award. And also, again, in 2019, with 2 products included. So the EH series, which is GoodWe's new single-phase hybrid inverter designed for high-voltage lithium batteries. And then also the MT series, which is GoodWe's flagship CNI product. And that ranges from 50 kilowatts up to 80 kilowatts. And then GoodWe is the only inverter manufacturer globally to have achieved this award for 5 consecutive years. So quite a badge of honor that GoodWe wears. And then, so according to Wood Mackenzie, GoodWe is the #1 global storage inverter supplier. And this is, it's quite prevalent for South Africa, considering that South Africa and sub-Saharan Africa in general, we are GoodWe's largest market for storage inverters. So it speaks a lot to the progress that we've made in South Africa so far. And then I also mentioned this previously, but according to IHS Markit, GoodWe is a top 4 3-phase string inverter supplier, and also looking to climb up on that ranking. Okay, so here's an overview of GoodWe's storage inverter portfolio. Okay, and as we can see, you know, we start off with the ES series, a 3.6 kilowatt product for 48 volt batteries. And that goes up to our, what we have currently in production is a 3-phase 10 kilowatt inverter, which is our ET. And that's designed for high voltage batteries. We've also got what we call AC retrofit or AC coupled inverters, which are pure battery inverters without the PV component. And then, as you can see, GoodWe's value proposition is very well poised to take on the South African market, as as we have been witnessing so far to date. Worth mentioning is on the bottom right there, the product that's highlighted in yellow is the BTC or the ETC, which is a commercial and industrial storage inverter. It's not available to market just yet, but it is currently in development. And the BTC version, which will, it won't be the hybrid version, but it will be the battery inverter version, should be available to market hopefully by the end of 2020 is what we have earmarked. And that will consist of a 50 kilowatt up to a 200 kilowatt product. So it's going to be 50 kilowatt modules, which are stackable up to 200 kilowatts. And then soon to be released after that will be the ETC, which will be the hybrid version of that same product. Then So GoodWe's three-phase string inverter portfolio is, it starts off with a 10 kilowatt three-phase product, string inverter product, our DT series. And that it goes all the way up to, at the moment in production, 150 kilowatt HT series inverter. The HT series is a new range of inverter that GoodWe recently released in 2020, and we're seeing quite a lot of traction already on that product, becoming a very popular product, also in South Africa, and also highlighted in yellow is the again the storage inverter product, the ETC and the BTC. Again, it's stackable in 50 kilowatts up to 200 kilowatts, and it should be available to market pretty soon. Okay, and then these are the global battery storage companies which GoodWe have worked on in terms of compatibility. So as we can see, we've got BYD, all the global name brands, BYD, LG Chem, Alpha ESS, Pylon Tech, and also Dynas. Also the high voltage batteries, BYD, Pylon Tech again, LG Chem and Dynas. These are all batteries that GoodWe has worked with in terms of compatibility and communication with the BMS. And then also locally, as we know, there's some very credible lithium battery assemblers in South Africa. Some very good quality local lithium batteries. And we definitely like to support the local guys and view some of them as very strategic in our progress into South Africa and also Africa. We're working very closely with some of them for even in terms of international compatibility. And you're going to be hearing some announcements on this very soon. And then, so just for South Africa, the storage overview. So one very unique thing about South Africa is that South Africa has a very unique storage sector market in that it is not driven by formalized financial incentives. And it's one of the few markets globally, well, at least if we look at developed markets in the PV space. Most of them tend to grow off the back of incentives, whereas South Africa, the market is driven by the consumer's business case and also external factors such as load shedding. And there is now a small tax benefit for PV consumers, but this is definitely PV specific and PV related and not related to storage. So with that being said, I mean, the PV market and the storage market are very organic in South Africa, which is very unique. Okay. And then also, there are many advantages to the storage market in general, especially if we're moving into the larger scale storage, that South Africa can address. At the moment, we're just addressing the pure need for energy. But in the future, it opens up huge opportunities for topics such as smart storage and smart grid. And then for South Africa specifically, for GoodWe, South Africa is GoodWe's largest storage product related market globally, which we know, and I've mentioned already. And to date, a majority of GoodWe's revenues in the South African market have been from storage inverter products. And this is purely based on market demand and the business case for hybrids and storage products. And then, lastly, before I before we go into the poll questions and I turn it over to Warren for his presentation, just worth mentioning that, GoodWe has definitely dedicated their efforts, investment efforts to the South African market because of the progress that we are seeing here. And with that, we are growing our team, as we know, with technical support in both David and Warren. And I think we're also going to see more growth, in terms of headcount and support to the market. We've also bringing on quite a lot of new initiatives, support initiatives, with RMA and carrying local RMA stock for the South African market. So we've made quite a lot of headway and progress in the last year. And yeah, from my side, definitely a thank you to everyone who's on this webinar and who has been a customer of GoodWe. Looking forward to more. And with that, I'm going to just turn it over to Richard, who's going to put up some poll questions for us. And then after the poll questions, over to Warren, who will be doing his more technical presentation. So thank you. Over to you, Richard. So then, yes, if you guys don't mind answering those questions quickly for us. So what is the best aspect when using GoodWe hybrid inverters? And then question number 2, which battery brand do you prefer when installing GoodWe hybrid inverters? Okay, and then with that, I'll move it over to you, Warren.
Morning, ladies and gentlemen. Thanks for joining us today, and thanks, Stephen, for the wonderful introduction. My name is Warren Alliston. I've been active in the PV industry since 2008 as a student at the University of Port Elizabeth, where I did a lot of research work with the postdoctorate students until I completed my master's myself in 2013. From 2013 up until now, I've been active in the PV space. I've been active in the utility space, the commercial and industrial space, and the residential space. So I've had the pleasure of experiencing all aspects of the market share in South Africa. So today I'm going to be talking about the design and installation considerations when using GoodWe hybrid inverters, and I would like to just introduce the products first of all. So GoodWe in terms of the hybrid products, offer 5 families at this current stage. There are lithium-ion batteries. We offer both single and 3-phase hybrid inverters. The product families are the EM series, the ES series, the ESA series, and the ET series, all of which are NRS 097 compliant and may feed back to the grid where the local permission has been granted. The GoodWe hybrid inverters have a transfer switch of 10 milliseconds or less. So when the grid fails, there's a seamless transfer of power sources. Another great aspect about the GoodWe inverters is the full unbalanced load, with the three-phase series being, which is the ET series. Connecting your inverter to the internet allows for viewing of the data and remote configuration virtually anywhere in the world, as long as you have an internet connection. Something worth noting is the AES series should be released in South Africa in the future, which will be hybrids greater than 6 kVA. So just an overview of the hybrid family. So we can see that there are three EM series. We've got 2 ES series inverters, 1 ESA, 3 EH products, and 4 ET products. All products are lithium-ion ready and self-adapt to the BMS. What's critical when considering these inverters is our battery voltage, to select the right batteries, as the high voltages differ from the low voltages. What's also worth noting is the backup power presented by the different family of products. So understanding which products can deliver the energy required for your appliance loads is very important. And as you can see, we deliver from 2.3 kVA all the way up to 10 kVA. And worth noting is the incredible efficiencies that GoodWe hybrid products offer, especially in the high voltage range, battery to load efficiencies. The EH series, we're looking at a peak of 96.6%, and with the ET series, 97.5%. So over the time of the plant's lifespan, you save many, or you deliver many more kilowatt hours. So some advantages when using GoodWe products compared to others. When buying a GoodWe inverter, you are supplied with everything required to complete the installation. We provide smart meter with CTs. We supply the wall mounting brackets, the required plugs, covers, and manuals, which are not always included with other products. So there are no hidden costs. Some other advantages using GoodWe is the monitoring platform is free of charge. All you have to do is hook up your inverter to the internet, and you should be able to access your data from anywhere in the world and see what your PV system is delivering. Another advantage with GoodWe, which I've just mentioned in the previous slide, is the excellent conversion efficiency. The max load to battery to load efficiency on the low voltage products is around 94%, and the high voltage products greater than 96%, which is absolutely fantastic. Another advantage with GoodWe products is the high input range for the PV DC, so you can string long strings of panels, therefore reducing the need for string boxes and the extra costs for putting the system together. So with the ES series, we got a max voltage of 550, and for the ES and the ESA, 580. For the EH single phase, max input voltage of 580 again, and then our three-phase products offer a maximum voltage of 1000 volts. Another important advantage using GoodWe products is the fact that we've won the All Quality Matters Award through TUV Rainland, and the specific hybrid products which have been included in that was the ES series inverters in 2015, the SVP inverters in 2017, the ET inverters in 2018, and recently the EH inverters for the last year. So the design considers overviews. What we're going to be chatting today about is e-system operation and understanding how the different work modes for GoodWe inverters work. We'll be talking about zero export, as exporting in South Africa is still not all finalized through all municipalities, and exporting to the grid is not always possible, and we do fully support zero exports so that net metering applications do not have to be completed for municipalities which do not allow for this point. We're also going to be looking at the peak demand. We need to understand the capacity required from the inverter and the batteries so that we can deliver to the load. We need to understand the energy requirements. So we'll be looking at the sizing of the PV array, the sizing of the batteries. And then we'll be illustrating the balanced and unbalanced loads, ET inverters. So the string sizing, the most important aspects we're going to talk about will be open circuit voltage, our maximum power points voltage, the string design, the MPPT, and the short circuit currents. The battery considerations we'll be going through today is the approved list of batteries. We're going to be looking at the discharge and charge currents. We'll be looking at the effects of temperatures on batteries, which is not well understood. And we'll be mentioning round trip efficiency, which always needs to be considered when sizing the system. And then lastly, we'll be looking at the system location, that is the mounting of inverter, spacing of equipment, and again, the temperature and ambient effects. So GoodWe offers 4 work modes with the hybrid inverters. It's the general mode, the off-grid mode, the backup mode, and the economical mode. The most common mode used in South Africa is the general mode. So how does the general mode work? In the general mode, the inverters will operate to meet self-consumption as far as possible. That is, the PV will support all loads first, both your essential and non-essential circuits, then charge the batteries, and lastly, supply to the grid where you're allowed to do. Zero export is achievable in this mode. The second mode is backup. In backup mode, the inverters will keep the battery charged until a grid failure has occurred and the battery and the inverter will take over from there. Again, zero export is achievable. The third work mode, which is not very common, is the off-grid mode. And in this mode, all the loads need to run off the backup circuit. So it's absolutely critical to understand that load fully so that the right product is introduced to the project. And then the fourth mode is the economical mode. So in this mode, the user can decide when the battery is charged and discharged and to what extent. This mode here is most useful for time of use tariffs. For example, in Port Elizabeth, their net metering works on time of use. So this economical mode can be used to maximize the return on such projects. Okay, so the first thing we need to understand when deploying GoodWe inverters into the market is we need to understand the customer's load profile. So on the right, I've an example of a typical load profile, and throughout the day we can see the different peaks. This is obviously geyser, the kettle boiling a few times, again the geyser, and dishwasher, washing machine, and then we have a base load which is around 500 to 1,000 watts throughout the day. So when performing an energy audit, we need to understand the resolution of the data. Most data loggers used in the field give a resolution of 1 hour. That can be quite challenging in terms of understanding the load, because if we do 1 hour resolution data, a peak of this, like this one here, will average out to less than 3 kilowatts. And if this is put up onto the backup circuits of the inverter, which say is restricted to 3 kilowatts, we'll have overloading problems. So I always recommend using a product which can monitor the voltage, current, power factor at least in 1 minute's intervals, at best 1 second. And this gives you a full and complete understanding of the customer's loads. I also recommend using products with multiple CT inputs. so that you can measure the specific loads, for example, plug circuits, light circuits, swimming pool, security systems, because we need to understand how those loads will be split up and can the product support the loads. So inductive and capacitive loads, these loads will need to be put onto the non-essential side. GoodWe products do not support inductive and capacitive loads with large store currents. These type of circuits like air conditioners, massive pumps, these need to be installed on the non-essential side to ensure that the inverter and batteries are not overloaded. The next thing we need to understand from the energy audit is the average daily use and the min max requirements, so we understand how much PV is required and how much battery is required to deliver solar PV to the load efficiently in the projects. The next thing we need to understand is the peak demand from the customer's load. So we need to understand all these peaks and how the PV system may deal with these peaks. So these are critical in sizing the system. Should you want the system to provide the full load for this peak here, for example, we'd need to have PV of in excess of 5 kilowatts. Okay, then we'd also need to understand if the loads are three-phase, single-phase, obviously, to choose the right products. Okay, so in the load considerations, what are the questions we should be asking? One, can the PV support the peak loads? So we look at products offered by GoodWe, and the peak load in this case is just over 5 kilowatts. We'll look at the nominal apparent power to the utility grid, and we've got a possible solution here with the GoodWe 5 kilowatt EM, with the GoodWe 5 kilowatt ES can do a majority of that load, and both the GoodWe 5000 EH and the 6000 EH can deal with that peak load in terms of PV. Then the next thing we need to understand is, on the essential circuits, is it required that these appliances run? And if so, can the inverter support these peak loads? So if we look again at these peak loads, we over 5 kilowatts. So if we had to use the EM series, unfortunately, that cannot support the load, and we'd have to look at alternative products. In this case, the GoodWe 6000 EH would be able to deliver this 6 kilowatt to the load. So in splitting the load correctly, you may be able to supply an inverter like a EM inverter, which can supply the base load, which is less than 2 kilowatts, and supply the PV when the grid is connected with 5 kilowatts. Some examples of acceptable AC loads and unacceptable loads. So computers, TVs, lamps, ceiling fans, refrigerators, small cooking appliances, refrigerators and freezers are acceptable. Some examples of unacceptable loads would be water heaters, air conditioners, electric cooktop ranges or ovens, spas, saunas, and water pumps, specifically water pumps without any soft starts. You have a very large store current. Then another thing we need to consider is, can the battery support peak loads? So when considering battery, we need to look at the discharge currents and have enough batteries support the peak load as well. We'll get to the battery section shortly. So understanding the wiring and configuration of the system. Here's an example of how a hybrid inverter is connected to a grid. In this example, this is three-phase. For single phase, we just do not have these phases and these CTs. As you can see, backup loads, the essential loads is split from the on-grid loads. The inverter speaks Modbus to the smart meter, and the smart meter gathers the data required for the inverter to understand what is being used, delivered to the utility, and very important for zero exports. So how do we achieve zero export with the GoodWe inverters? Again, it's through the smart meter connected to the hybrid inverter, and through the PV Master app in the advanced settings, we can export power limits on all GoodWe hybrid inverters. Some further load considerations for three-phase applications, specifically in residential homes, the loads are typically always unbalanced. The great aspect about the GoodWe ET inverter is it can support unbalanced loads to 3.3 kilowatts per phase. That meaning you can have 0 kilowatts on, say, for example, line 2 and line 3, and still be able to deliver a full 3 kilowatts on line 1. Okay, then this example here just illustrates the unbalanced load. So you can have 1, 3, and 2 kilowatts over the phases supporting the unbalanced load, and the GoodWe will export 0 kilowatts per phase to the grid. For larger solutions, the GoodWe ET inverter can be paralleled up to 10 units using the SEC 1000S. This is the way the system would be configured. The backup loads cannot be paralleled, so each inverter will have its own set of backup loads, but the peak PV demand to support the small commercial system or very large residential can support all the large loads on the on-grid side. Okay, so PV requirements. How much PV do I need? So once you've completed your energy audit data and you've worked out the average daily consumption, you can look at the general rule, which the PV capacity is equal to your daily average consumption divided by your efficiency factor times the peak sun hours for that specific tilt and orientation. These are calculations that you will not have to worry about when using our easy design tool. All of these calculations are handled through the simulation package, and none of these equations have to be put into Excel and done manually. This can all be done achieving the easy designer tool. So hybrid series inverters have either 1 or 2 MPPTs depending on the model. Systems with 1 MPPT should have all modules in one plane. What does that mean? Is all the modules need to be on a single roof structure facing the same way at the same tilts. If you do not do this, you'll have mismatch, and mismatch causes severe inefficiencies and stresses bypass diodes. Systems with 2 MPPTs may have 2 arrays, each array having its own tilt and orientation, and again, should not have any mismatch in the same string, which will cause inefficiencies and stress bypass diodes. The hybrid series inverters have very specific DC MPPT input ranges. So the easy design tool does these calculations in the background. So the number of modules you can have in a single stream is determined by this equation here, which does the temperature correction for the coldest conditions. Again, we also need to consider that the MPP voltage of the string needs to be within the MPPT range of the inverter, and that is then determined by this equation here. So you'll have a maximum number of modules and a minimum number of modules to work with. But again, the easy design tool does this for you. Another aspect that we need to consider is the short circuit current of the panels to the inverters. For the low voltage products, we've got a maximum ISC of 13.6 amps. And for the newer high voltage products, 15.2 amps. The 15.2 amps allowing for bifacial modules and the maximum yield from them. This is the equation here to determine the IC max. Typically 25% of the IC of the STC rating of the module, where the IC of the string is the parallel strings times the IC module. Using standard poly or monocrystalline panels, you'll typically just have one string going into the inverter. When using thin film, the parallel strings will come into effect. Again, all of this is handled by Easy Design tool, and I encourage the installers to use this tool, as it does provide a lot of information. It gives yield estimations, which can be very beneficial in the sale of the products. Okay. Moving along to the battery considerations is, first of all, again, through the product range, the low voltage series, we work with 48-volt batteries. The high voltage series on the single phase, 85 volts to 450 volts. And on the three-phase series, 180 volts to 600 volts. Another very important aspect is the charge and discharge current for each product family. For the EM, we see 50 amps is the restriction. For the 3.6 kilowatt ES, 75 amps. For the 5 kilowatt ES, 100 amps. Very similar for GoodWe's ESA. It's 90 amps charging max, but 100 amps discharging. And then very important with the EH and the ET series is a max charge and discharge of 25 amps. So to achieve your maximum outputs on the inverters, we need to achieve the right voltage in the batteries to get that. So you would have to stack enough batteries in series to achieve the full load output. So another important aspect to consider with batteries is temperature. So the desired working temperatures for lithium batteries is typically around 15 to 35 degrees, where you'll get your maximum charge and discharge. Anything below 15 degrees, we start getting sluggish electrochemistry. The electrons are cold, they don't want to move as much, hence we cannot get as much out of the battery. Moving above 35 degrees, we get side reactions which cause degradation. Therefore, the BMS will limit the charge and discharge current to prevent damage to the batteries. So if we had to look at the load example again, the peak here specifically, we call it 5 kilowatts. To deal with that peak on a low voltage product, we would need 100 amps. And to achieve 100 amps, we need to look at each battery and understand what each battery can deliver in terms of current, so that we can stack enough batteries to deliver the loads. So, can the battery deal with peak loads? Do I have enough batteries? Can my backup produce enough power to support my loads? And here are some simple calculations which I've put together, which can assist in the calculations. For low voltage batteries, the number of batteries you require is the discharge current required divided by the discharge per battery. This differs for the high voltage batteries. The number of batteries required is the nominal DC voltage at full output power divided by the nominal voltage per battery. And then another consideration we need to understand for the number of batteries is the amount of storage required. So we look at the number of batteries as the daily average consumption divided by the efficiency factor times the depth of discharge we set the daily cycle to times the battery capacity. And the number of batteries would be the larger calculation between this and these two, depending whether you're using low voltage or high voltage. Efficiency factors in systems are typically around 80 to 85%, and that can be used as a general rule as to determine the size of the system. Then we also need to consider efficiency. So let's, for example, say we've got a 10 kilowatt hour battery. For the battery to deliver 10 kilowatt hours, of course, we'll need to put in more than 10 kilowatt hours because it's not 100% efficient. So we need to consider this when deploying systems. It's the round trip efficiency, which is the amount of energy put in, amount of energy put out over the rated capacity. Again, typically around 80 to 85%. Okay. I just would like to go through the approved batteries with you guys. Stephen's already mentioned some of them, but I would like to just expand onto that. So LG, they are approved for the low voltage range, ES, EM, and SBP. These are their battery models which are compatible with the products. Then we have Pylon Tech as well. A recent compatibility is the Force H2 has been announced compatible with the BH, EH, BT, and ET. For the low voltage products, we look at the US 2000 and the US 3000 for the ES, EM, BP, and SBP. For the high voltage, we look at the PowerCube H1 or the H2, which covers the ET, BT, EH, and BH. Then there's Soluna battery. The Soluna battery is specific for the ET, not too well known in South Africa. Then we have Alpha ESS. We have got 3 product categories compatible with the low voltage products offered by GoodWe. And then there's Dynes. Dynes has a wide product range offering solutions for all GoodWe hybrid inverters. These products over here for the low voltage, and the tower products here for the high voltage. BYD is another brand supported by GoodWe. Again, they offer a wide variety of products which are compatible with the full range of GoodWe hybrids. Worth noting is there is work being done with the local assemblers, and simply we should be stating which suppliers are compatible with GoodWe moving forward, and we look forward to that. Okay, so moving to the Easy Designer tool, this is a simulation package which is developed around the GoodWe products and aimed at assisting installers correctly design their systems which are to be installed. So for the guys that do not know this product and haven't used it before, if you go to the GoodWe web page, you go to the support tab, and at the bottom, select System Design. It will take you to the Easy Designer homepage, and from there you can create an account and start working on projects. So in creating a new project, there will be 3 categories which you can see: grid-tied, hybrid, and retrofits. Select the hybrid storage products and push OK, and you can start inputting all the data required to fulfill the simulation. In the first tab, we'll have energy consumption, which gives you options for a daily usage ratio, annual consumption, or monthly. As we know, people's energy consumption changes through the month, so I suggest understanding how the customer uses the electricity throughout the year and understanding what percentage is used during the day and what percentage is used at night. After that, we can move to the plant configuration. In the plant configuration, we can define PV arrays, we can define the orientation and tilt, we can select our module manufacturer, we can select the number of modules, and define the AC power requirements, 3-phase or single phase. And then there's an option to automatically design the system or a manual selection of inverters and batteries for the design. If choosing manual, you need to be careful not to exceed the limitations of the inverters. So once you've selected which inverter, which batteries, we will get to this tab over here, which will give you warnings and tell you a little bit about the system design. I created this simulation to highlight a faulty design where I've put 12 modules in series on NPPT1, and we can see we exceed the input voltage, and it gives us a nice warning in red. I also undersized the number of panels on tracker 2 with only 3. And as we can see here, it's giving us warnings telling us we're under the MPPT range. So taking all of this into consideration, we can relook at our design, reconfigure it, and change our stringing inverters and batteries. So I reconfigured it here to 9 and 8 batteries. As we can see here, we have no warnings. In tracker 2, no warnings. And in the dialog box, there's no information to change parameters. Once we reach this stage over here, we can move on to the next part of the design, which is the cable consideration. So here you can choose your material, your square millimeter of cable, and how long your cables are going to be for both trackers, or one tracker should you be using a smaller product. And you can also do the same for the AC cabling. Once this has been complete, the outcome will give you this dialog over here, where you can also generate a report. So it will show you the product you've selected, the number of inverters, the number of PV modules, the module area, the annual generation, the amount of cable loss, which batteries you have selected, power ratio, and then very nice, gives you a sketch diagram of how to connect the system to the utility. At the bottom, it gives us a monthly generation forecast, which can be presented to your clients so they understand month to month what they can expect from the system. Moving on from the Easy Designer tool, we need to consider the system mounting and layouts. So very important to get this aspect right. On the right-hand side here, I've got an example of a poorly installed system, and at the bottom, a well-installed system. So the system above here, should the client need support on the product, cannot get into the SENS portal, we require a serial number, they will not be able to get to the serial number. As well, there's not enough space left to right, causing heating issues and causing duration of the product. Again, underneath, you cannot service the product. So this here will be very difficult should you need to do a Wi-Fi reset and get into the Wi-Fi reset button. Looking at the system below, the inverter's got enough space left to right, top to bottom. All the connections are very accessible, well laid out, and all the warning signs have been labeled. So the restrictions with GoodWe is it's a fanless design, so it uses a heat sink and natural convection. We cannot tilt the inverter in this orientation, but we can tilt the inverter to a maximum of 15 degrees in this orientation. And this sometimes is very useful when doing a server cabinet design, and it can help reduce a little bit of space. Otherwise, normally on a wall, if your wall is not perfectly straight, it's not a problem. You can do up to 15 degrees. Other important aspects to remember is the inverter must not be installed near flammable, explosive, and strong electromagnetic equipment. It needs to be out of direct sunlight, so a canopy, no exposure to rain, again, a canopy, and not so prevalent in South Africa, but not exposed to snow. On the left-hand side here, illustrating the correct manner to install it. Thank you guys for your time. And I look forward to the questions you may have for me, and I look forward to supporting you in installing GoodWe inverters to the markets. Thank you very much for your time. Richard, could you please go to the next poll? So the first poll question is, who is your preferred solar PV distributor? It's a multiple choice. You may have more than one preferable distributor, so you can select more than one there. Question 2, which parts of installing GoodWe do you find challenging? This is a single answer question, and we look forward to seeing your answers. Thank you very much.
Sure. And yeah, just while you guys answer that, thank you, Warren, for that. Yes, after we've finished with this poll question, we're going to move it over to David, but we'll give you guys another minute or so just to answer those questions.
Hi everyone, David Hammacher here. Just going to run you through the basic installation, highlighting on the ES series, which is the most popular, but the new setup steps and commissioning and everything is more or less the same for all of our hybrid inverters. So we're going to be going through what's in the box, the product overview, the mechanical installation, electrical installation, commissioning, monitoring, resources available, the remote configuration, and fault finding. So with the ES, as well as all of our other hybrid inverters, they will always come with the components that is required for the inverter to work correctly, as the smart meter. So the ES has the single-phase smart meter. The three-phase smart meter is the same profile meter. It will just come with 3 CTs. All of our CTs are 120 amp rated. So if you're using a 3-phase unit and the customer is a much larger incomer, we might have to look at using a different solution. As you'll see, we give all the correct MC4s and connectors for the inverters itself. So it's always recommended to use the provided connectors on the inverter itself. If you use other connectors and it does lead to a failure of the connector, unfortunately, we can't assist much with that. So it's always recommended to make sure you use the provided connectors. We also have the battery cover and the AC cover as well. So it's 2 covers that look like this. One is for the battery terminal and the other for the AC terminal. We do include a few lugs and things for your battery cable connections, your AC cable connections, and your neutral connections. With the ES inverter, the Wi-Fi module is separate and needs to be installed separately, where some of the other models you will find that already installed. In the box as well, you'll find the user manual and the quick installation guide. The quick installation guide contains a lot of installation guidance for our approved batteries. Just a brief overview. I think Warren went mostly through this. So most of the considerations you'll see is on the sides, below, and for the installation. So I see there was a poll question regarding trunking below the inverter. Should the trunking not be right against the unit, it is fine. It is generally recommended to keep it a certain distance away so there's sufficient airflow for the bottom of the device. On the side of our inverter, we do have the LED indicator. This can also be found in the manual. So should you have any problems with the Wi-Fi, first point is always to look at the Wi-Fi LED to see what it is telling us. So we can follow the different steps in the fault finding to know exactly, is it not connected? Is there a server problem? As well as the fault light is another light that we pay a lot of attention to. If it is blinking, that means the inverter has overloaded. So if it is constantly blinking, that could be that it is in a overload state and waiting for the overload timer to count down. So for the mechanical installation, we do provide a easy to use wall bracket, and the bolts, but sometimes depending on your wall structure, you might just provide your own bolts to mount this. So you'll see we do provide the dimensions for the unit when spacing to leave, so that you can just measure this out on the wall, or you can just use the bracket against the wall to measure. The inverter simply hooks up on the bracket, and then you can secure it with a securing lock if that is required. You'll see the ground cables should be connected to the outside of the inverter. Here's just a brief overview of the installation for the ES inverter. So you'll see we've got the on-grid input, which is the bidirectional grid input. Then we've got the backup output. So depending on your grid type, you'll see this is a unmarked terminal. So in South Africa, we'll generally connect this terminal up to the backup, to the earth terminal as well. That will just ensure that we don't have a floating neutral should the grid fail. Very important, the smart meter. The smart meter will always be powered by the grid itself, and the CT in the correct direction as close to the power meter as possible. This is so that we can read all the loads consumed in the property itself. The backup loads, and then we have our PV as along with the PV DC disconnect under the inverter. So let's always make sure that after connecting the strings, then we just switch this on. You'll also see the Wi-Fi module sits here. Then we have our battery connection. Always pertinent to double check your polarity and have a DC breaker or a fuse in between your batteries and the inverter. I'm not going to go too much into the compatible batteries. So for the battery installation, it's always recommended to use a decent crimping tool to make sure you get sufficient torque and make sure that we don't have any hot connections and any melting cables in future. So whether you use the provided battery terminals or use your own lugs, that's perfectly fine, as long as they are suitable. And when you crimp them, that they are securely fastened to that. It's always good to give this a good tug to make sure that it is on there securely. Our glands below do allow for up to 35mm square cable. And always put your cable through the connector before you put your lugs on. Because should you put lugs in, you can sometimes battle to get it through the actual gland. And I state, be very careful of the polarity. We don't want anything blowing up. Same for our PV cables. Generally, most of our inverters you should, I think our standard now is MC4. So you'll always find the MC4 connectors. It's also always advisable to use a proper crimping tool to make sure that there's no loose connections or hot connections. I've seen this too many times in the past where we don't use a proper crimping tool, and that can end up melting the whole terminal, and it's just not a good sight to see. So for the AC connections, you'll see we've got the 2 ports as well. We also have in the manual, you'll see the recommendation for the recommended conductor size, the wire length of the conductor as well, and you'll also find the ferrules in the packaging as well, just to make sure that we have a good connection for the cables that you are using. Using a ferrule like this also helps to prevent that we stick the cable in too far and we just secure it on the plastic of the cable. It's always advisable to do it. It's just good practice to make sure we use the ferrules. You'll see the torquing of the terminals. We do recommend a 2 to 2.5 Newton meter torque, just to make sure that you don't over tighten and strip the terminals. But they are pretty resilient, and I've not stripped one myself, so they are fairly good terminals. So for connecting the Wi-Fi on the ES, you'll see it is completely loose and there is a white cable hanging out. That simply gets plugged in. It can only go in one direction, and you fasten the 4 screws that hold it. So the smart meter, it's very important to get the best out of your system to make sure that the smart meter is properly installed. If the smart meter is not communicating correctly or it's not properly corrected, you might get conditions happening on your inverter that will be unexpected, like putting it in self-consumption, if it doesn't discharge the batteries at all, if your seat is in the wrong direction, the inverter also will not discharge the batteries for self-consumption because it is reading export. And should it read export, then will then make sure that the batteries are full. So the inverter comes with the cable to the meter. It is 10 meters, but that can be extended to 100 meters should the main DB board be quite a bit further away. I know some customers just install this in their incoming board to the inverter if it's far away from the DB, but then you really do not get the best out of your system if that's not reading the entire house load. So for commissioning, you use the PV Master app. Most of you should be quite familiar with the application already. So this, we connect to the solar Wi-Fi of the inverter. The solar Wi-Fi password, I'll show it a bit later as well, is 123456778. We open then the PV Master application. That will then scan for inverters. We can select the inverter and then we can browse to the settings page. In here, it will ask us for a password. That password is GoodWe 2010, all lowercase. So the first part of our setup will always be our country code. Our menu structure has changed a little bit from this, where it has a drop-down list. So you'll select Africa and then select South Africa. So that is just to set the inverter to use the South African grid parameters. Then we go through to select our work modes. I won't go too depth into work modes since Warren has covered this for us. Thereafter, we go to select our battery modules. So one thing that you need to that you'll know in the battery module selection, should there be a battery that is on our compatibility list and you do not see it in this list, that just means that your inverter's firmware will most likely need to be updated for it to appear in the list, because the inverter firmware does give through what is displayed in the app. So after you've selected your batteries, you will move on to the meter test. So the meter test is not compulsory. I know some customers do battle with it, but when we perform the meter test, we need to ensure that the grid and everything is on, that everything is in a running state. We also then need to make sure that there is sufficient current being drawn from the grid. So that will generally entail switching on a few appliances, even on the grid connection side, opening the tap so the geysers can run. Just make sure that we're drawing current from the grid so that when we are testing, that there's current flowing through that CT. Normally, if all is well, it should take a minute or two and then report everything is correct. Sometimes on the older firmwares on these inverters, the meter test doesn't work as well. I'm not going to go too much into this. I think Warren did cover this reasonably. I just want to highlight which sometimes is a misunderstanding. So we've got the depth of discharge on grid and the depth of discharge off grid. So we somewhat need to see these as separate depths of discharges. So setting this doesn't reserve a certain amount. So this just says to what state of charge do we take our batteries. So the off-grid is normally recommended to just use the maximum amount for the battery type that you are using. So in this case, I think this was a big BYD pack, so we could set it to 90%. And then the depth of discharge on grid, we can set to 50% or 40% to make sure that we reserve some battery for outages. Where backup mode will only listen to the off-grid depth of discharge. It will ignore the on-grid depth of discharge. You'll also see the charge current and discharge current in the application here. These figures are dynamic. They do change based on the requirement of the batteries. So this is reported from the battery BMS and it's not a configuration setting. Another thing with the economical mode, we've got our start times for the charging and discharging time. Yeah, you've got rated power. That is the rated discharge power of the batteries. So should you have a smaller battery pack that only gives you 50 amps, setting it at 10% will then mean a maximum charge rate of 5 amps. So for our backup only mode, this is the default setting, which is 10%. So that's just a slow UPS charge. Under advanced settings, we've got the export power limit. So in most instances, this will need to be enabled. So we can set the maximum amount of power going out to the grid. So if we can't export, this will be set to 0. If we are limited to a certain amount, so for instance, in Cape Town, if we have a 60 amp breaker and we only limited to 3.5 kilowatts, we can set this to 3.5 kilowatts to ensure that we do not export more than that to the grid. Shadow scan is not a widely used feature. That's only more for very shaded areas, so that the inverter itself will stop tracking completely and retrack to find the best power point. The backup supply should be on by default. So regardless of which work mode you are using, you'll always have backup supply. If you are using the inverter just as a grid tie inverter in the meantime, it's not recommended to use the backup output. So I would always then recommend you can wire it up, but leave it on a changeover so that nothing is running through the backup circuit. Then you'll find the off-grid output switch. The off-grid output switch is not visible when the grid is enabled. So if the grid is on the inverter, you won't see the switch, but this switch does come on automatically. Should you be in an off-grid scenario and you trip your inverter off for exceeding the battery discharge or an overload or any condition like that, this switch does go off. So we will hopefully soon have a firmware that will help this to auto reboot in an off-grid scenario, but currently the only way to switch your unit back on, should you overload it during an off-grid period, is to come in the app and re-enable this. If there is multiple sources, so if you do have solar, it will reboot itself as well. You'll see we have the power factor adjust. This is normally just recommended to leave on 1. you only really adjust this should you have bad power factors on site, but that needs to be tested, and then you can adjust it to correct the power factor. But it's generally not recommended to adjust it on a domestic home. We then have grid quality detection. It's always recommended to have grid quality detection on. That is the active monitoring of the grid. So what happens if you disable this is that you can have a delay in changeover. So if this is off, you'll notice lights flickering. If you have computers or TVs, your TVs and stuff will shut down during the changeover, because the changeover then is more about half a second. So because you've disabled the active grid quality detection. Below this, we also have low sensitivity. Low sensitivity also does delay reaction to the grid itself, but sometimes if we have a grid that's behaving badly, that frequently just pops in and out of range, you can enable the low sensitivity. Sometimes you might also see a delay in backup, but not as long as when you see grid quality detection off. So if you do put that on and you are having changeover problems, you can just switch that off. That's all for the PV Master app for now. So now we've done the settings of an inverter. Now we need to connect it to the customer's network. So you can use a laptop, or you can use your phone. Some people find it much easier using their laptops to do this. So you connect to the solar Wi-Fi. You'll find the 1, 2, 3, 4, 5, 6, 7, 8, the Wi-Fi password. Below the inverter as well, you see the Wi-Fi reset button. So should you have any issues with the Wi-Fi, so if your customers change their router or anything along those lines, and you need to reset this because it's trying to connect to the customer's network, so the solar Wi-Fi is unavailable, the only way to do that is with the reset button below the ES. On some of our other models, the EM and the ET, we do have a button on the screen. Also, you'll notice here, we do have our ports available. So all of our newer inverters, you'll see this is the broadcast address and broadcast port. So sometimes on home networks and business networks, you'll get our Wi-Fi LED goes to full blinking. So full blinking is we aren't communicating with the server. So if there's a firewall in place or some sort of parental blockage on a home network, we always just need to make sure that we can open the ports then for the inverter so that it can communicate outwards. So very often this can be an issue on sites where we go into full blinking, and we just need to double check that this is open for us to communicate. So once we've connected to the solar Wi-Fi with our laptop or with our phones, the true and tested method to connect the Wi-Fi is through the web browser method. So you open your web browser, you go to 10.10.100.253, you click connect. So when you're doing this on a mobile phone, you'll see it always gives you two options. It gives you the globe option and the search option. Make sure you connect the globe option so that you connect directly to this. You'll then see it opens up the dialog page to log in. The username and password is both admin under lowercase. So when you open up, you'll see we can see quite a bit of information. We can see the MAC address and everything for this device. So should you want to look for it over customer's network, that's a good indication for you. We can also see the Wi-Fi firmware version here, and I'll just show you how to update that a little bit later. So then we click the Start Setup, a nice blue button here. And also, if you come into this page and it might not be in English, that does sometimes happen with older devices, you'll see on the top right corner, there's an English button that you can click, then it will all be English for us. So we then click the blue Start Setup button. You'll see the inverter will then scan for local available networks. We can then check for the customer's network name. We look at the RSSI tab, because this RSSI is the actual signal strength. Yeah, we can see this strength in percentage. If we see it's a bit low, we can also hit the refresh button to see if there is interference. So if a a signal strength is jumping up 50% and then 20% and then 50%, then we can be quite sure there is quite a bit of electrical interference, and then a range extender might be required. So then we can just select the network we want and we can go next. You'll see it will then open up this page where we can then type in the wireless network password. So with the network password and all that, we just need to make sure that there's essentially one main character that does interfere with the connection is a blank space. So very often people might put a blank space like my space home. That blank space isn't fully recognized by the inverter itself. So the inverter may connect to the customer's network, but it won't be able to broadcast outwards should there be a blank space. Sometimes the blank space in the network SSID can cause this as well. So you see by default, this should be on this network encryption method, which is one of the standard network encryption methods. I know some customers may have older network devices. If they do, they can just see if that is available. If it's not available, they will have to update their router to make sure it can connect. Now, updating the Wi-Fi. So it's quite the same step. We connect to that page where we have the management. I'll just go back quickly to show you. So we have Wizard, Advanced, and Management. So we'll browse to the Management page. So from the Management page, we'll see a select file. There we just need to make sure that we use the correct firmware version. Currently, we have 3 firmware versions available. The oldest being the rack, that will most likely only be on inverters 2016, 2017 inverters. Then we've got the slightly newer one, which we used until Q3 in 2019. So just pay quite attention to the actual current firmware. So the new one, you'll see version 1.1. It'll be either 1.1, 1.2. Then we'll know it's an LBP 130 module, and that will use the latest LBP firmware. If you do download the firmware, that should be arranged in the correct folders. It is critical to make sure that you do not upload a LBP 130 firmware onto an LBP 100 module, because you will damage the module and it will be unrecoverable. So for the LBP 100 module, you'll see 1.0. So for this one, it's 1.0.3.8. So like I said, you'll go to the management page, you'll select the file, and then press update. It normally takes roughly 60 seconds or so. Then you'll see the solar Wi-Fi will reappear. You can then connect to it, and it should still retain the customer's Wi-Fi network parameters. If it hasn't retained it, you can just simply redo that setup. Now we move over to the firmware update for the inverters. So this is a local firmware update. You can also request a remote firmware update from us. The remote firmware update is normally much easier, but it does sometimes not work on older firmware inverters and if the Wi-Fi connection is unstable. If that's the case and there's no Wi-Fi on site, the local update can be performed. So you do need a laptop or PC, a USB male-to-male cable, the software, data send, and easy flash, and of course the instructions to be able to do it correctly. With the older EM inverters, if they have quite a very old firmware on them, you must just make sure that there is no PV on when you update these inverters, because it can damage the inverter. And if the inverter already has the latest firmware on it, it's not advised just to reflash it with the same firmware over again. So if you contact our support or your distributors for support, they should supply you with a download link for the latest firmware files. So you can always download these. The link that they should send you will always be a live link and always contain the latest firmware. So before you go to site, you just download it again, and make sure that when you get to site, you have everything with you. It's very important to make sure you use the correct firmware for the correct inverter. So under each inverter, you'll find a USB port. They can sometimes be in different locations. For the EM, it's below the Wi-Fi dongle. For the ES, it's behind the meter port. So it's quite simple. You just undo the 4 screws and pull the Wi-Fi dongle off, or on the ES, you undo the 4 screws, loosen the meter cable gland, and you pull the cover downwards. Below there, you'll see the USB port as well as the Wi-Fi reset for the ES. It's always recommended before you do your updates to shut down your unit. Make sure it is in an idle state, so just put on one source. For the ESs and others, you can just put on PV or just batteries. First, we're going to do the data send application. This can actually be done while the unit is in full swing. It does not reboot the inverter. It doesn't affect the power controllers of the inverter. So the data send is a very nice and easy update. And like I said, some inverters that are on a very old firmware won't be able to be updated remotely, and they may have Wi-Fi on site. Then all that is needed is to do the data send on the inverter, which will then update the ARM chip of the inverter. So if this is updated, then we'll get a much better connection to the portal, and then we can follow up and do the remote update for the DSP. So this is quite simple. You connect your USB into the inverter, you click here to choose your firmware file, and you click this button, and it will then update. Should you see the open USB file, that means the inverter is not properly communicating with the computer. Very often you just pull the cable out, turn it around, pull it in again, and you might find then USB open success. So if it's connected, you just press this button. It will say data send, data send, data send, and you'll see a green bar run across. So once that's completed and you see data send complete, you can just close the application and data send is completed. If you would then like us to do the DSP remotely, you can then request this from your distributor or from our support website. But if you are going to do the local update, the EZ Flash tool is then used. This can be tricky on site if there is any electromagnetic interference, or if your computer might have some viruses and have a USB port that doesn't always work as well. It's then advisable to not do this locally and get the device connected so that we can do that remotely for you. So what the EZ Flash does is it physically erases the DSP, which is our main power controllers. And after erasing it, it then uploads the new firmware to it. So should it fail during an update, the inverter won't be in a usable state until the update has succeeded. So it's quite similar. You'll connect it to the inverter. You'll see the connect box. So if it's not communicating with the inverter, the connect box will be available to click. If it is communicating, this will be grayed out. We just need to make sure that the ARM box is ticked. You can untick this. It can update without the ARM box ticked, but you can then expect your firmware update to take around 45 minutes. Sometimes when there is bad interference, we can untick this and then run the update, because it runs it a lot slower so it doesn't lose packets. We then go through to select file. You'll see there is a master file and a slave file. It is critically important to select the correct master file and the correct slave file. Should you swap these two files around, your inverter will be bricked and it will have to go back for repairs. So unfortunately that will make sure that your inverter doesn't work. It can also lead to the corruption of the control board. So sometimes it will be unrepairable. So it's very important to make sure we select the correct files. Also in our download files, you'll see they will be in separate folders, one called master and one called slave. So once we've selected our files, we press OK and we go to update both. You'll see it will run through. We'll see master update success, then it will go through and run slave. Should your slave fail and your master has gone through successfully, you can also just use update slave in your retry attempts. Like I say, sometimes it does fail if everything was selected correctly and there was some electromagnetic interference. You can just switch the inverter off again, leave it for 15 minutes or so, make sure the USB is out, nothing's powered on. Reboot your laptop as well for good measure, power on the device, plug in the USB again, and then try again. Normally that then allows us to update it successfully. So now that our device is on the latest firmware, it's connected to the customer's portal, we can move on to the monitoring, which is the SEMS portal. So for the SEMS portal, if you don't have an account yet and you just want to go and view and see what the different values and things you can see on different kind of inverters, you can just click on demo and it will take you to a few demo sites where you can see information. Should you be a new customer and you want to register on the SEMS portal for the first time, it's generally recommended then to contact your distributor so that they can create an installer's account for you right off the bat. If you don't have an installer's account straight away, you will unfortunately not be able to get an installer's account on that same email address until you have more than 5 plants on your site. So we do have a new feature available to upgrade you to an installer once you have more than 5 plants on your SEMS portal. So if you don't have an installer's account, so easy way to see whether you have an installer's account or not is to log in. You go to settings, my account, then you'll see there's a distributor code. If you do not have a distributor code and you have more than 5 plants, you'll see on that page an upgrade to installer button. You can simply click that upgrade to installer. It will tell you it has now successfully been upgraded. Please log in again. You'll then see, if you come back to the page, you'll have a distributor code. So on SEMS portal, we can do a lot of load monitoring. I'll show you a bit more in depth for our fault finding, where we go to see a bit more information. But we just have our general power, our self-use ratio. We'll see the interval load monitoring. So this is a snapshot of every 5 minutes from the inverter itself. So this currently does not update dynamically. So every time you refresh your page, you'll see this will change, but that will be a 5-minute interval snapshot of what was happening on your inverter. Lastly, we also have our energy statistics to see your PV generation versus your load consumption. So should the CT and everything be installed correctly, all your values here will be quite accurate. So on our website, we have quite a few resources. We have user manuals, certificates, and even a bit of software. So if you do need a user manual or the quick installation guide, or to see our battery compatibility sheet, you can simply go onto GoodWe.com, go to our support and downloads. There you'll find you can choose the document type, certificate, user manual, or software. You can choose the product series. You can choose one, or you can choose all of them as well. And then you select your language. You then hit search and it will give you all the available documents for that. Some documents you might not find under a specific product. Then you can just go straight to the bottom of that page. You'll see there's a search function. You can just type there, search for instance the PV master manual. You just type in PV space master, hit search, and you'll find that manual. So for our installer accounts, we have remote configuration. So this is available for our storage inverters as well as our string inverters. So anyone that has an installer's account on the SEMS portal simply needs to have the plants under the installer's code. So if you did update, you'll see that all your plants will now have an installer's code under it. Then you can just open your mobile phone app. You select your plant. You scroll all the way down to the bottom and you'll see your inverters on your plant. Select the specific inverter because you can only do one inverter's configuration at a time. It will open up to the inverter information and you'll see the blue configure button. You press the configure button, read the terms and conditions and agree. Thereafter, you'll see all these menus. So these are just about all of the settings. There are a few advanced settings that aren't available here, but just about all of them are here. So you'll see we have the country code settings, the battery settings. So especially for customers that want to randomly adjust the on-grid depth of discharge to make sure that reserve more battery power, or change the work mode to backup when we have a lot of load shedding to make sure the battery is 100% full. You can do this remotely and there's no need to go to site to do it. So to do these settings, there has to be a stable Wi-Fi connection to the inverter, and the newer the firmware on the device, the better the settings work. If the firmware version is, the ARM firmware version is below 8, these settings may not work at all. So then we move over to fault finding. The first place is where you can go when you've got a problem. So if your customer is reporting their backup is shutting down for some or other reason. So if we go into our SEMS portal on the website, below we'll see the energy flow, and then we have the devices tab. So in the devices tab, you'll see if you've got multiple devices on the plant, you can select them here individually. So you'll see an arrow here to scroll through the different plants. So also to see the individual inverter information, you can also come here. You'll see the curve here. That opens up this window for us. In this window, we've got a drop-down list here. You'll see you can scroll down, 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 and this goes quite far. So you can go to your P backup, you can go to your grid voltage, you can then go and see it with a graphical interface to see if there is anything obvious that could be like an overload especially. You'll see a nice peak on the graph, and then the backup dips off. So that will then generally indicate that an overload has occurred. Very often we can also come and see why am I discharging my batteries past the SOC that was set. You can come in here, see your grid voltage. Sometimes you'll see the grid voltage may exceed the NRS regulations, and then the inverter will then switch over to discharge from the batteries. You may even sometimes find that you'll see your discharge limit here, which is dynamic from your batteries, is a lot lower than what it's supposed to be, or it's 0 and your batteries are 100% full. So then you know that's coming from the batteries itself. So you can even see there's a charge I max, and you can see all the different times when the battery reports different charge and discharge currents. So this gives us a good general indication of what's happening with the system. It does take a bit of time to learn all the different ins and outs, but it's a good starting point at fault finding always to see what has happened. Secondly, for the installer's accounts, you'll see you've got an alarm tab. So a lot of the alarms that happen for a certain period of time, you'll be able to see on this alarm tab. So you simply go to the alarm tab, you'll see there's a status. This will normally be on happening. So if it is currently happening, you'll see it with the inverter. If it's happened, or you'll see there's an option for recovered or all. I generally select the all. You type in the plant name or serial number. You'll normally have to type it in here, wait a little while, and then it'll pop up, and then you can click it to filter it to that plant. You'll see it then lists the plants for us, the alarm which it is giving, as well as the status. So you'll see this one is a VAC failure, status is happening. And so you can also click on the details. So this will give you a bit of detail regarding the failure and the possible reasons for the failure, as well as troubleshooting. But please note some failures may not show up here. So if it is a momentary error, or the error reports only once in a cycle to the device, then it may not appear on this. So if we are having unsuspected errors and we cannot find the reason for that after looking at all the different sources, we can then either log a ticket or speak to your distributor to assist you with that. So like I said previously, some alarms may not show on the SEMS portal as well. So if you go to site, you connect with your PV master, you go to the param page, you'll see there's alarms. So this alarm, so the inverter itself stores up to 100 alarms. So it's a good place to come and look to see what alarms your inverter has been giving. So this will also give us a good indication. So yeah, you can scroll through the alarms to see more of the alarms. Very often you might see something like this, a pre-fault operating mode or a pre-fault. So this is very often just, it's a pre-alarm, so it's not an actual alarm. So yeah, we'll see 512, 512. This is all VAC failures. So it's generally nothing to worry about. So if we do have an alarm that the inverter has shut down or have a condition that we not like, we can always come here and it will then give us the ID and fault code. One thing to keep in mind is that we are constantly, especially on the newer firmwares of the inverter, constantly updating the error codes that can be viewed and improving the fault finding for us. Very often the app may not have that, and then you'll find a fault code 0. So a fault code 0 just means it doesn't have the app itself doesn't have a definition yet for that fault code. Diagnose message. Diagnose message you'll also see available in the settings menu. So this isn't necessarily alarms. 99% of the time it's not alarms. It's just the actual diagnose message is the inverter logic. So it describes conditions that it's using in its logic to make decisions. So you'll always see messages here for one or other reason. Very often, if your batteries are low, it will say cannot discharge. If your batteries are full, might give you SFC over range. So you'll get a lot of different diagnosed messages here. Some of them may not make a lot of sense, but generally, if there's not a problem on the inverter, there's no reason to look at diagnosed message. We have had lots of customers in the past, especially end users that don't have access to basic settings and the passwords and that. And then they send us tickets. Why is my inverter giving a lot of error codes? But this is nothing to worry about. It's simple operating logic. And thank you for your time. That's all from my side. I think we'll have another poll now. If Richard can just put it up for us. And then we'll be sitting here and answering all the questions in the Q&A for you for a few minutes until you guys are finished.
Thank you, David. Yeah, I hope you guys are, I hope all the attendees are getting some very good information out of this. Ideally for us, we would normally want to be doing these types of trainings, face to face and maybe a little bit more hands-on. But yeah, given the circumstance, I think this is the best case for us at the moment. And yeah, also know there's quite a lot of information that has been presented. But yeah, hopefully all very good and valid information for you guys. Richard, can we get those questions up? The poll questions.
It is. I can see it's up.
Oh, is it there? Okay. All right, and then yeah, we'll give you a minute just to answer those poll questions. And then, as David mentioned, we'll go through some of the Q&A questions that have come up, some of the more common ones that we receive. And then we'll, between myself and David and Warren, we'll answer those for a while. We'll probably give it about 25 to 30 minutes for answering those questions. And then, yeah, we'll round it up from there. Okay. Yeah, I see that most of the questions that have been asked have also been answered. Yeah, what I'll do is just go through some of those questions, and as a very appropriate question comes up, I'll point it to either David or Warren, or answer it myself. Just the first question that was asked is, will the BTC be available to the South African market? Just for everyone's reference, again, the BTC is going to be the commercial and industrial AC retrofit inverter. So not a hybrid inverter, but just for battery application. And that will be followed by the ETC, which will be the full hybrid inverter. And it's going to be 50 kilowatt modules that can be stacked up to 200 kilowatts. Again, our team, our R&D team, are working on this product in development, and we have it pegged to be released for production by the end of the year, which means that it will be available to market or for purchase early next year, in 2021 for the BTC. And then the ETC will probably follow approximately 6 months after that. It is a very highly anticipated product. Every time we mention it, we get quite a lot of interest in the product. So we are also very excited to be able to eventually release it to market. But yes, because it's still in development, we don't have finalized data sheets or spec sheets on it yet, and we don't have pricing. So I know that that's always the first question from anyone who hears about the product. But as soon as we do have more information on the product, we will be releasing it. Yeah, just going to look through some of the questions quickly. And then, so there were a lot of questions about the local support of, the support of local batteries, such as Solar MD and Blue Nova, Freedom One, amongst others. So maybe also for me to address that very quickly is we are collaborating with, definitely formally collaborating at the moment with Solar MD and also Blue Nova for compatibility. As soon as the tests are completed for the compatibility, we will be announcing the official compatibility of the product. Yes, but it is a little bit of a process on our side. But for those of you who do install Solar MD and Blue Nova and even Freedom One, all companies have, together with GoodWe, worked on the protocols and the communication with the BMS. They do successfully communicate, and there are already successful installations in the South African market with those batteries and GoodWe inverters. Okay. Okay, sorry, I'm just paging through some more of these questions just to find one or two that would be technical questions for David and Warren. Okay, David, maybe you can answer this question. So do you know where we can get high voltage pylon tech batteries in South Africa in order to use the EH hybrid inverter and also the ET inverter? Because yes, they've been looking for high voltage batteries for a while. So I know you did answer that in text. Maybe you can just give an overview there for everyone.
Yeah, so there are several, like I know Pylontech, there are quite a few distributors. Some of these smaller Pylontech importers are also bringing in the high voltage batteries. Rubicon does have a range of the high voltage Pylontech batteries, which they do bring in. But there are a few smaller distributors. I don't know all the name. I think one is GC Solar. They're also a small Pylontech importer. I do know one of another customer that also resells them is Arden Solar. So there are a few guys out there that do resell Pylontech, that do import it directly, and they do stock that. I do believe Seagen Solar themselves will also quite soon be stocking the high voltage batteries, most likely Pylontech and or BYD. Kranich, I know, will probably also be stocking the BYD high voltage, hopefully before the end of this year.
Yeah, thanks, David. Warren, maybe a question for you. How does the three-phase inverter support unbalanced loads if it's essentially only a single inverter?
Hi, Stephen. I'm not sure of the exact mechanics around that, but essentially inside the ET, you can view it as 3 single inverters under one cover. So each phase is independently looked after by the inverters. So I'd have to find out the exact mechanics from Solar Academy to answer it in detail.
Okay, yes, and also just to add there, based on Warren's response, because we do see this quite often, you know, when we mention that the three-phase inverter, the ET, for example, can manage unbalanced loads, we must keep in mind that with it being a 10 kilowatt inverter, each of the phases are limited to 3.3 kilowatts. Okay, so three phases of 3.3 kilowatts, obviously totaling 10 kilowatts. So the unbalanced loads that can be managed will be for each phase from 0 to 3.3 kilowatts. As long as we are in that range, then there's no problem at all. But any one of those phases will not take on additional capacity on behalf of the other two phases. So very important there for any three-phase installation is to balance the loads as much as possible. The more the loads can be balanced, the better off for the system. Okay, David, a question for you, because it's definitely a more support-related topic. Have we managed to sort out issues with grid limiting on some smart meters?
Yeah, so this is it's most pertinent on the Conlog meter. I think there's one or two other little meters that also have reverse feedback protection. So sometimes there is a leakage, even 5 or 10 watts, can cause these meters to trip off. So our R&D is working on that. We should have a firmware release. I'm just waiting for confirmation within this week or next week. Well, this week's already over, but we do have a newer firmware, and I am just confirming and testing that this is working correctly. But we do hope to have this out quite soon. This will then allow us to adjust a negative export value. So instead of going to 0, you can put -50, -100, just to make sure that there is always a positive flow from the grid to ensure that those meters do not trip off.
Okay, thanks, David. David, also again, another one for you. It's regarding the ET inverter again, and the question is, can batteries be paralleled on multiple ET inverter installations?
No, so unfortunately not. The high voltage battery bus is a non-isolated battery bus. So if you parallel them, the inverters can damage one another. So it's not recommended to do that at all. it's always advisable to look in our manuals. Our manuals do have that. You'll see it will be perfectly laid out what you can and cannot do as well. So it's always good to reference that before you design the system, you can download the manuals of our inverters and just double check whether you can do that configurations.
Thanks, David. Then also, yeah, I did see, I think it was 2 questions regarding the Easy Designer and having more cities available in the South African market on the Easy Designer, and then also maybe just updating our database for battery compatibility. So we have taken note of that, and we will be putting that forward to the internal development team, just to make sure that, yeah, that the city coverage for the Easy Designer is a bit more comprehensive. Then, yeah, just a question for Warren, just regarding ventilation and trunking with the installation of inverters. Warren, do you have anything to maybe add to your typed response there?
So with the trunking is not to put the trunking up against the inverter or equipment, as to not create a place where heat can build up. So you can put the trunking underneath as long as it's not blocking the airflow. And should you be putting the inverter into a cabinet, the cabinet should not be fully enclosed. There should be ventilation and possibly forced air into the cabinets to prevent the equipment from overheating.
Okay, thanks, Warren.
Stephen, I'd just like to add, I can see there are quite a few panelists that people have posted in the chat and not in the, I think there's about 9 questions. If you guys will please just ask those questions into the Q&A section. You'll see next to the chat is the Q&A. It will be appreciated. Thank you.
Yes, and also anyone who's still on the webinar that has any pending or urgent questions that you would like to ask the panelists while we're still here, you know, anyone from the GoodWe team, this is a very good opportunity to do so, you know, as we're drawing to a close with the questions. So yeah, we'll try and answer as many as we can. And then also worth noting is that everyone will be getting a recording of this presentation together with the actual presentations themselves. So yeah, more for your benefit there, and you will also have our emails and contact details, and also support channel contact details. So yeah, please, yes, as David mentioned, any questions in the Q&A section, and we'll try and address those as best as we can. Okay, I've got a question about when the EH model of inverter will be available in South Africa. So I can answer that in that it is, we already have an order for those from one of our distributors that is headed to South Africa. It's currently being collected in China. It is a limited order, so there won't be a tremendous amount available, but it is to get the product into the market and to create awareness around the product. One thing to consider about the EH, it's a single phase hybrid inverter up to 6 kilowatts, but it requires high voltage batteries, you know, for the design and the installation. So something to keep in mind there, but it's definitely a product that we see a very big future for in South Africa as high voltage batteries become more available in the market. Okay, I see a lot more questions have come in. So there's a question for you, Warren. Often there will be 2 or 3 fails on most installs with the correct connection message on the last. For the last 3 times ES installs, I've not had a problem with incorrect direction messages. To be honest, I'm not too sure what that is referring to. Warren, do you know?
So this is referring to the energy meter when you do the CT test. Mr. Milan has said there's a couple installations where when they perform the test the first time, it fails, but then afterwards it succeeds, and they would like to know why that succeeds. So we would have to dig deeper into the actual installation to find out. Maybe with David's experience, he may have the answer already.
Yes, so for the CT meter test, like I say, very often if there's not sufficient current being drawn from the grid, it can fail. Also, if the inverter has a much older ARM firmware, if the ARM firmware is lower than 8, the CT meter test doesn't work at all. So I know there was quite a few inverters that had like ARM 5 on them. So if ARM 5 is on that inverter, most likely the meter test will keep failing and keep telling your CTs in the incorrect direction. So if it does fail and you know it's correct, I mean, the meter test isn't a vital part of the functioning of the system. So if you can see via the actual data that everything looks fine, it's normally nothing to worry about. But we can then also update the ARM firmware of the inverter, make sure that there's sufficient load being drawn, and then we can do the meter test again. Then normally it does succeed.
Thanks for your input, David.
And then if I can add, so not specific to the question, but more about just the support channel. So there are 2 support channels that can be used. The first one is also, is through our website under the support tab. There is a channel there where you can either search for your, for more common support questions, or you can input your support question. And that will be directed to the correct people internally. The second thing is obviously, if you know David and have a relationship with David, please, very important is always to work with your distributor first and foremost, so that they are also aware of the support issues that we might be experiencing, and also for us to be able to understand, from the distributor's perspective, what are the more common support aspects for us to be able to address with them. But David is also, as an after-sales technical manager, will also be available for any local support if required. But please always try to use your distributor and the online support channels first and foremost. Okay. Then getting to some more of these questions. Do you recommend an automatic firmware upgrade on any installation? David, I think that one's a good one for you.
So I'll just click answer live. Yeah, so it's always good to make sure that your inverter is on the latest firmware. Some devices, some of the ES devices manufactured end of 2018, it's always good to make sure that they over DSP 15. So you need to make sure it's either 17, 18 or the new 20 that will be coming out soon. So it is always advisable to make sure that it is on the latest update. So you can always request via our support line. So you can also go on our website. You just go to support and it will take you to our support site. Then you can just log a ticket. We on the back end will just see what is your firmware. If it's connected correctly to the portal, we can then just remotely update the firmware for you. So the only thing to keep in mind is that when we do the DSP update, the inverter does reboot.
Okay, thanks, David. And then another question, any issues with Landis or, I don't know how to pronounce that, Guyr meters, Guyr meters. David or Warren, are you familiar with any of those meters?
Where's that question?
From Pierre Kalitz.
Yes.
I'm not sure if he's referring to prepaid
Yeah,
meters.
Landis and Gear meters. Landis and Gear meters. No, we've not had any problems. Landis and Gear meters generally don't have the reverse feedback protection enabled. So normally there's no issues with them. That they only give like a little warning light to say that you are feeding back if there is any exporting. So the only thing that really happens with most of the energy meters, if there is a little bit of power leaked through, it's still counted as usage. So it will reduce the units, whereas the conlogs and things like that have a reverse feedback protection, and they can be very sensitive, even like say 5 watts for a few seconds, then that meter trips off.
Okay. Thanks, David. Is there anything to add there, Warren?
I understand with the conlog meters, if you engage with conlog, you can change that setting, that reverse feedback setting. I have a colleague in Port Elizabeth who has engaged and successfully changed that. So with the prepaid meter tripping, I suggest contacting the manufacturer to see what is possible.
So generally conlog would refer you to the actual. So it depends the council that it's in. So some councils are very strict, and conlog will then tell you that the council needs to request this service. But sometimes if you're lucky, they may assist you.
Okay. Then I've seen this question a few times already, so maybe worth addressing is, what about supercap battery technologies? I'm going to start off with my response, but I'll also hand it over to Warren and David to elaborate on anything. We are definitely, so as a company, I would say maybe a little bit technology agnostic in terms of batteries. The most important consideration is more the BMS and the communication between the inverter and the battery or the storage technology. It just so happens that most technologies available on the market that are gaining commercial traction are lithium iron phosphate based. I can't speak for supercap technologies. The only thing I do have there is an opinion on it, but nothing based on fact. And haven't really investigated or looked into the technology much myself. But again, all the batteries and the storage products that we do support are products that are commercially available and that we find strategic for our various markets and globally. And have a credible reputation in the market. And that's not to say supercaps don't, but it's just it hasn't come across our desk for us to be able to investigate or work with at any level of depth. I apologize if that doesn't answer the question specifically, but that is pretty much our stance as GoodWe. And David, Warren, I don't know if there's anything you want to add there.
Yeah, so
Yes.
we have had this in the past as well. So we are open to any battery manufacturers to approach us, that we can look at getting them incompatible. So I think for our compatibility requirements, we do require communication. So if there is no communication, I don't think they'll be able to pass our compatibility tests, because the test is part of the test is the communication. So we do have sort of an open protocol in our settings with the default lithium. We've got the 50 amp hour and 100 amp hour default lithiums, and what those protocols do is take all the settings from the battery BMS. So many batteries that will be approved, like Solar MD, like Blue Nova, like all the others, they may not be physically on the list to select, but you can then select default lithium, and that will then automatically pull the parameters from the battery. So I believe the supercapacitors do now have CAN communications. I've not seen the specific module that has it, but we are discussing that with some of the suppliers of them to look at getting them in the process of approval. But it is a process, and generally the battery manufacturers will approach us to have that done.
Is there anything you want to add there?
Yes, so with batteries that do not have communication, we need to understand that there's no signal coming from a BMS preventing charge current or discharge current according to temperature or any other parameter that the battery may be limiting for. So you run risk of tripping your battery unintendedly, and it may cause damage. So we do not advise using lithium batteries without BMS control for this reason.
Yes, absolutely. Yeah. Then another question is, can we host a training for distributors to help installers with faults on site? So that would be absolutely ideal, and that would, outside of COVID, that would definitely be our approach, is to work with our distribution partners and do on-site installer trainings. Unfortunately, as we know, that hasn't been possible so far this year. But with that, with David is very capable. Both David and Warren are extremely capable with on-site support, although that is David's main function. That is the best that we can offer at this time is information on through this webinar channel, and then also either support through the distribution channel, but also through David for any on-site support. Okay, question from Miguel, who's got a business infrastructure in Portugal and is asking if we have export price lists in euros. Miguel, we've got a European team, quite a big and strong European team that's headquartered in Munich for the EMEA region. Yes, we've got quite a big presence in many European countries, obviously, and we stock product in the Netherlands for the European market. And we've usually got stock available in Europe for Portugal. So best, I would say, is to email me directly, and I can put you in touch with the European team. So another question from Davis, who seems to be in Kenya, in Nairobi. Do we have a distributor there? So the quick answer to that is we don't have an official distributor. We have been supplying into Kenya through various channels, but we don't have a formal distribution partner there just yet at this time. Okay, there's a question from Davis. David and Warren, I don't know if you know what this is about or how to answer this. It's a little bit unclear to me, but can inverters be used where we have boundary metering and not as boundary meters?
Unfortunately, I don't understand the question to answer that properly. If Davis could maybe rephrase the questions in a little bit more detail so we can understand it?
Yeah, no, it's it's a bit unclear what we're not familiar with the terminology that he's using.
Okay. Okay. I think that's everything pretty much for the questions. I can't see any that we haven't covered. I'm just going to quickly look through the chat box. Okay. Yeah, I think that's everything from our side. So with that, I think we're gonna close off this webinar. We want to thank all the participants for joining us today. We trust and hope that you guys got a lot of value out of this webinar with the information. Also, a big thank you to Warren for helping organize the webinar internally on GoodWe's behalf. And then also to David for your presentation. Very excited at the prospect of what's ahead for us in the South African market. We have been growing quite substantially in the last year, even with Corona, which is very unusual, and we're very grateful for, and looking forward to working with everyone in a lot closer as we develop our infrastructure into Africa, and helping us become really successful on the continent. So thank you, everyone. With that, we're going to close it off.
Thank you, Stephen. Thank you, David. And thank you for everyone for joining us today. I hope it was educational, and we look forward to engaging with you guys in the future.
Cheers. Thank you, Warren. Thank you, guys. Enjoy your weekends. Cheers. Bye.
Thanks again, guys. Ciao. Bye.